Hello, welcome to this lesson of our study of integral equation. And I guess for now I would stop the integral equation lesson for now, and some other time I will start solving questions or teaching how to solve Volterra's integral equation. For the various methods we've been doing is specifically for Fredholm's integral equation. Okay, so we'll do that one of Volterra's at that time. Okay, so the next lessons will be a different set of math topic lessons. Okay, all right. So if you have not subscribed to my channel, kindly subscribe and let's start. So in this lesson, we just go through how to convert a VVP to an FI using Green's function. Okay, so that one too is possible. So let's go through it and know how we go about it. Okay, so our task here is to convert the given BVP, this one, to its corresponding FI using Green's function. Okay, so like this. So we have y prime plus lambda y equals x, and this is subjected to the boundary condition y of 0 equals y of pi over 2. Okay, so I hope by now you know how to find the Green's function and the rest. Okay, but before that, let's quickly remind ourselves of something. We said that when you have something like this, you write this in a general form as d squared y ds squared plus, lambda y minus x equals 0. Okay, so this, if you want to convert this one to an FIE using Green's function, then what you do is we compare it to the general form of this. The general form we said is p plus, or p d squared y ds squared plus dp dx. Okay, or you can call it q. Let me put dp dx to be q. Okay, q dy dx plus some ry plus some phi of x equals 0. Okay, so this is what we always consider. But here, what we want to consider here is that this time around, since phi here is just a function of x, okay, we want to consider it, or when you want to convert the BVP to an FIE using Green's function, what you do is you make sure that the function here will be a function of both x and y. Okay, so here you see, here we have a function of only x, so the phi here should change to a function of both x and y. So with the ry will also go, and we'll have something like phi of xy, okay, equals 0. So we'll only be concentrating on this aspect. Okay, I hope you get this. So we'll concentrate on this aspect, and the remaining will be a function of both x and y. Okay, so with the explanation I just gave, our function, or our question here is y prime okay, plus lambda y equals x. So if I send the x to the other side, I have y prime plus lambda y minus x equals 0. So you can see that if I want to find a function of both x and y, then it should be all these. Okay, I hope you understand this. So it means we'll get something like y prime plus some phi of xy. Okay, phi of xy or yx, anyhow you want to call it, is okay. Xy equals 0, where your phi of xy is the whole. So it means that phi of, let me write it, phi of xy is actually equal to lambda y minus x. Okay, so this is what you have. So it means that if I expand this one, okay, from the question given, I'll have something like d squared y ds squared plus phi of xy equals 0. So you go and compare this to the general form dp, or let me write the general form here. It's a p d squared y ds squared, okay, plus q dy dx plus phi of xy. Okay, I hope you remember what I just wrote. Okay, this is what I'm trying to write. Okay, if you compare this to that, then our p here in this contest, or in this question given here, it means that our p is actually equal to 1. So let's keep this. And you know how to find a Green's function. So you find a Green's function using the homogeneous part. So you just pick this part. So if in case the dy dx was present, then you pick all of these aspects as well, okay? But here you only have the second derivative present, okay? So you said you pick d squared y dx squared, okay? So d squared y dx squared is the same as y prime and it's equal to 0. You put that to be the homogeneous part and you solve this. Okay, there are so many ways you can use to solve this, okay? And one of the methods is that since this is a second order differential equation with constant coefficient, what we can say is that we say our function be e to the rx, and we find y prime, which is r e to the rx, and y prime which is r squared e to the rx. So we put this y prime in place of the this aspect, okay? So I have r squared e to the rx equals 0. So based on this y prime is equal to this one, okay? So it means I have two products of function that is equal to 0. This is not equal to 0 because it's our function, and if it is equal to 0, then you don't have a function, okay? So you have r squared equals 0 rather. So it means r is equal to plus or minus 0, because when you find the square root of 0, you have repeated roots. Remember, it's a repeated root. So I have 0 or 0. So I have to get two roots for a quadratic function. This is a quadratic equation. And quadratic equation always provides two solutions. So we have 0 or 0. So it means it's a repeated root, okay? This means that, let me write my solution here. We know that it's a repeated root with the root being 0. So it means that our y of x, we said when it's a repeated, we have x, or let me say ax, okay, ax e to the r1x, okay, plus, let me write my r1x, and plus b e to the r2x, and both r1 and r2 are 0. So when I put 0 here and 0 here, I'll have e to the 0, and e to the 0 is what? 1. So I actually have ax plus b. So you realize that most books will tell you that the solution to this y prime equals 0 is ax plus b, and that is the reason, okay? This is it. So we should use the boundary conditions to state or to find out if indeed a Green's function exists for this particular question, okay? So in the boundary conditions, we are saying that with the boundary conditions, y of 0 equals y of pi over 2 and is equal to 0. So y of 0 is equal to 0, okay? Y of 0 is equal to 0, and y of pi on 2 is also equal to 0. So with the first one, y of 0 equals 0 means that wherever I see x in this, I put 0 there. So I have 0 being equal to a into 0 plus b, which implies that b is equal to 0 because a times 0 will give me 0, okay? And y of pi on 2 is equal to 0, okay? So it means that wherever I see x, I put pi on 2 there. So I have 0 is equal to a into pi on 2 plus b, which is 0. So I have plus 0. And I have a times pi on 2, okay, equals 0. Now if I divide through by pi on 2, I have a equals 0. And indeed, we'll have y equals a 0 times x will give me 0 plus b, which is 0. So I have y of x equals 0 being the trivial solution. So since the trivial solution exists, so you should always check. Sometimes the question will ask you to find a Green's function, but you realize that the trivial solution is, or the trivial solution does not exist for this one, and then you just conclude that there is no Green's function for this, okay? Now, since we've known that the Green's function exists, the first point, we say that g of xt, which is our Green's function, should be a piecewise function consisted of two functions, okay? And all of them should be in the form of this. So I have a1x, the first one, g1 of xt should be this, b1. Then we said the lower boundary less than or equal to x less than t. And the second one is a2x plus b2, then t less than x less than or equal to 1. Sorry, it's pi on 2 rather, okay? So this is my Green's function, okay? So the next task is to find your constants a, b, A1 and B1 and the rest. Okay, so the second point is that the Green's function should satisfy the boundary conditions. Okay, so the boundary condition is y of 0 is equal to y of pi on 2 and is equal to 0. So it means y of 0 equals 0. And now I'm going to come to the Green's function. The 0 is part of the g1 of xt. Sorry, g1. This is g1 of xt, and the second one will be g2 of xt. We've had a lesson on Green's function already, so I presume you understand this. If you don't, please, I will urge you to go back and then watch that video on Green's function on my playlist. I have a playlist of integral equations, so just look for the Green's function in that integral playlist, and then you come back to this. Okay, I'll give the link to that video in the comment section. Okay, so we said that g1 of 0 comma t. Okay, g1 of x. Let me first write g1 of xt for you. Actually, g1 of xt is equal to the a1 x plus b1, although we only see x here, but we assume it is a function of both x and t, and indeed at the end we get a function of both x and t. Okay, so we said that with the first one, the y of 0 belongs to the g1. Okay, so g1 of 0 comma t is equal to 0. Okay, it should be equal to 0. Everything here is equal, so it's equal to 0. It means that a1 into 0 plus b1, and this should be equal to 0. This means that what we have, this a1 times 0 is 0, so plus 0 plus b1 equals 0, meaning this implies that b1 is equal to 0. Okay, I hope you get this. So we go to the second bound, that is the upper boundary, and then with the upper boundary we are saying that it belongs to the g2. So g2 of xt is actually a2 x plus b2. Okay, and g2 of pi over 2 comma t is equal to a2 into pi on 2 plus b2, and we are saying that this is equal to 0. Okay, so this implies that either way, let me see this. This implies that a2, okay, or you can say b2. I can make any of these the subject, but let me make a2 the subject. A2 is equal to minus 2b2 over pi minus 2 of pi b2. You can actually do it like that. So it means that I just took this equation, okay, and made a2 the subject. So you can go through that. Okay, we've done a lot of videos or a lot of things on Green's functions already. That is why I'm just jumping those steps. Okay, so let's call this one equation 1, that is a b1, and call this equation 2. And yes, okay, let's keep that one. Okay, and go to the third point. The third point is saying that g1 of tt should be equal to g2. Okay, g2 of tt. Let me write it well. We're saying that g1 of tt should be equal to g2 of tt. And we know g1 and g2. So g1 is a1x plus b. So wherever I see s, I put t there. So I have a1t plus b1 should be equal to a2. The g2 is just a2x plus b2, and wherever I see x in that, I put t. So I have a2t plus b2. Okay, so now with this one, what can we say? We know that b1 is 0, so I have a1t equals a2t plus bt. Okay, plus b2. So we can actually also, or we can say that this is also another equation 3. Let's keep it like this. Okay, now with the fourth point, we say that del G, in particular with the second order OD or second order BVP, we say del G of xt del x at the point x equals t should be equal to minus 1 over p of t. And we know p, we said, that's why I first so that you should note this: p is equal to what? 1. So p of t will still be 1 because it's a constant function. So it means that here I can clean it and put 1 there. So I have minus 1 over 1, and that will give me minus 1. Okay, so let me put minus 1 here. Now with the differential of this, we say we differentiate this piecewise function like this: del g2 of xt over del x at the point x equals t minus del g1 of xt over del x at the point x equals t is equal to negative 1. So differentiate g2 with respect to x and we'll get a2. Okay, when you simplify this at the point x equals t minus differentiate g1 with respect to x and you have a1. Okay, differentiate at the point x equals t and is equals to, or evaluate at the point x equals t and get minus 1. But we don't have any x in D, so I have a2 minus a1 equals negative 1. Okay, this simply means that my a2 is also equal to a1 minus 1, and this is equation what? 4. So from equation 4 and 3, let's go and check for 3. Okay, I can put a2 here because in equation 4 I have an equation involving a1 and a2, so I can quickly put a2 in place of this side. Okay, and see if I can do some simplification. Okay, so from equations, let me just write from 4 and 3. Okay, from 4 and 3, so I'm using the both. Okay, so 3 states that a1t is equal to a2t. Is it minus? I don't know. Let me check that one. Yes, a1t equals a2t plus b2. So with this plus b2 and this equation 4. So if I put a2 in place of this equation, I have a1t equals a1 minus 1 t plus b2. Okay, so I have a1t equals a1t again minus t equals b2. So if I pick all of these to the other side of the equation, and this is plus b, there's a plus. So if I pick only this side to the other side of the equation, okay, then I'll get something like a1t minus a1t plus t equals b2. Okay, this take this out and I have b2 being equals to t. But if you remember from equation 2, so from 2 we said that a2 is equal to minus 2 over pi b2, and b2 is what? T. So I have minus 2t over pi, and that is really cool, right? Alright, so I have in equation 4, in only equation 4. Okay, so from equation 4, we have a2 being equal to a1 minus 1. So a2 is this, so I come and put it here. So I have minus 2t over pi equals a1 minus 1. Okay, so I take the minus 1 of this to the other side of the equation. I have 1 minus 1 comes to the left side of the equation. I have 1 minus 2t over pi, and it's equal to a1. So I have my a1. Okay, so I have a1 being equal to 1 minus 2t over pi. I have b1 being equal to 0. I have a2 being equal to minus 2t over pi, and you have b2 being equal to t. Okay, so this is all we have. So what you can do is go back to our Green's function, and the Green's function states that we said that g of xt is given by two piecewise functions, a1 x plus b1, okay, then a2 x plus b2, and the boundaries are these. Okay, x less than t less than x less than or equal to pi on 2. Okay, so since we know our a's, 1's, and the a's and then the b's, we just put them back. Okay, and a1 is what? 1 minus 2t over pi. I hope that is right. Yes. And x have 0 less than, and b1 is 0, so I don't actually write that. Okay, so to x less than t, and I have a2 to be minus 2t over pi. Okay, so I have minus 2t over pi x, then plus t, and comma with t less than x less than or equal to pi on 2. Now I can do another simplification here. Okay, so if I factor t out in these, okay, let me factor t out. Let me show you what I'm trying to say. If I factor t out, I'll get 2 t here will go, and t here will go. I'm factoring it out, and it will be like this. Now I have minus 2s over pi plus 1 times t. Okay, and then with minus 2s over pi, I can reshuffle and make it like 1 minus 2s over pi. Okay, so let me actually clean these and write it very easy for you. Okay, so that when you are doing our integrations, we'll get to some integration part. Okay, 1 minus 2x over pi times t. Okay, with this. So now we've gotten our Green's function, and I hope you know how we got our Green's function. We are saying that when you want to convert a BVP to an FIE, you make sure that you have your phi to be a function of both x and y, and then the remaining you take it as your homogeneous part of the differential equation and you solve it. Now you solve it. After solving it, then you use it to construct the Green's function. So after constructing the Green's function, this is how the FIE will look like. Okay, now you know the Green's function. Now the FIE is given by y of x is equal to integral of 0 to the limit, okay, pi on 2, then g of xt phi of x or phi of t y of t. You know, y is a function of x, so if I write phi of, or y is a function of both x and t, or let me see, with a phi of xy, okay, the y is still a function of x, so you can write it like the phi of x y of x, but saying phi of x y of x will make something, okay, it will just confuse us. So that is why we almost all the time we write phi of xy, so that it becomes easier. But when in working, this is how we see it. Okay, so it means that if you have your phi of xy, then you can find your phi of t y of t. Okay, meaning phi of t y. That is all. Okay, so we know the g of xt, right? So we know our phi of xy2 to be equal to phi of xy to be equal to lambda y, okay, minus x. This is what we have. But you know y is a function of x. Okay, so if I want to find phi of t comma y of t, it means that wherever I see t x in this, okay, I put t there. In this one I put t there. So I have lambda, then y is a function of x, so it means that a function of x here, there was supposed to be an x here, but we said wherever we see x we put t, so it becomes y of t and minus t, like that. Okay, so we just come back and put this in this equation and say that the FI is given by this integral from 0 to pi on 2 g of xt, then phi of t y of t is given by lambda y of t minus t, okay, then dt. Sorry, there's supposed to be a dt here. So this is the formula you should know. Okay, then after that you come and use your required or your particular file of ty of t in your question, and then you come and solve it. Okay, so our task here is to solve this. Now let's expand this side, because there's a some operator action here. That is the minus side. So when you do that, you have y of x being equal to lambda integral from 0 to pi on 2. I'm just multiplying this side to this g of xt, and that you get lambda g of xt y of t dt, and lambda is a constant, so lambda can come out. Okay, so I have that, and g of xt y of t dt, then minus integral from 0 to pi on 2 g of xt then t dt. Okay, I hope you can see this. Here there's only t, so it's minus t. Okay, so when you do that, that is what you have. So here we know g of xt, we have t, so we can actually simplify this part. But here we know g of xt, we don't know y of t. That is the function we don't know, so we can't continue with that part. That is what will give us an integral equation, specifically in the Fredholm's integral equation. So you can pick the second part, this one, and go and simplify it. So we pick 0, integral from 0 to pi on 2 g of xt times t dt, and this is equal to, now g of xt is into 2. Okay, so let me actually write my g of xt back, because I'm going to do something here. Or let me use the other page. I want you to understand. Okay, so kindly bear with me. I have g of xt being equal to 1 minus 2t over pi then x. Okay, now I have this range should be very, very important to you. That is why I just wrote it again. And 1 minus 2x over pi. Let me erase this part. Okay, 1 minus 2x over pi times t, then t less than x less than or equal to pi on 2. Now this is what I have. Now with this, what you do is, we say that we are coming to integrate 0 to pi on 2 g of xt times t dt. Now g of xt is a piecewise function. Okay, so this whole integral is equal to, first we break it in the range. Okay, let me pick the first g1. Okay, let me pick the first one, and I'll write its range for you. I pick this. When you pick that, the first g1, that is 1 minus 2t over pi times x times t, because it's every g of xt times t, so everything times t, then dt, then plus integral, because it's a piecewise function, so I have this integral of 1 minus 2x over pi times t. Here there's a t here already, so multiply another t dt. Now the question here is the limit. You just write everything back, but use the limit here. Okay, interchange the limit. I mean, the limit for the second one, use it for the first one. Okay, this is the first kernel. Sorry, this is the first g. Okay, this is our first g1. That's the g1. Okay, so when you write the g1, use the second limit for it. Please, I'm repeating it again. When you write the g1, use the second one for it. I mean the second limit, the second range, this one. And here we are integrating with respect to t, but I want to get a function of x. So you use range of x. So as you start from the range, you start from x and end at pi on 2. Okay, so it should start from x and end at here. Now with this one, it should start and end at here 0. We don't want any t in the range. Okay, so the range for the second one is x to pi on 2. We use that for your g1, so you should start from x to pi on 2 here. Okay, you write your integral of g1, and its range, like I said, it should be the range of the g2. Now with the g2, you use the range of the g1. Okay, so this is 0 to x. I hope you get this. So other books will also tell you that use the same range, but then interchange x and t. So when you come to the g1, instead of writing x here, you write t. Okay, and instead of writing t here, you write x, and you maintain this one. You realize that you get this. Okay, and you use the same range, and it's this. And when you come to the g2, instead of writing t here, you write x, Instead of writing x here, write t, and use the same range as this, and you realize that you get back this. So if you don't want to get confused about interchanging x and t, all that I will tell you to do is just write your same G1 and G2, but then use the range for G1 for G2. I mean, you use the range that is originally for G1 for G2, and you use the range that is originally for G2 for G1. I hope you get this. So that is the explanation I can give you. So we continue by expanding this one. This one won't expand. Okay, we won't expand this because there's no t in the bracket. But here there is a t in the bracket. So when you multiply x and t, you get xt. And multiply t and t, you get t squared. So I'll quickly just come in, and then what I'll do is I'll erase them and write their product there, so that in our next slide we'll just find it easier to do. Okay, so I have xt here and I have t squared. Okay, now the first one, when I expand, I'll have, where is my expansion? With the first one I expand, I'll get something like this. Integral from 0 to pi, sorry, it's not 0, it's x to pi on 2 rather. Now when I multiply through by xt, I have xt minus xt squared over pi. Or is it 2xt squared? It's 2. There's a 2 somewhere, so let me, 2xt squared over pi, then dt, then plus integral from 0 to x, and I have 1 minus 2x over pi t squared dt. So with this part, I believe, like I said, with this one there's no t in the bracket, so we don't expand. Now I integrate each of them term-wise. So with the first side, this one, I integrate xt with respect to t. I'll have x over 2 t squared minus t squared with respect to, because 2s over pi is a constant, so t squared with respect to t will give me 2x over 3 pi. I mean, I'll get 1 over 3 t cubed, but the 1 over 3 times this will still give me this. So this one, that is the first part, from x to pi on 2. Okay, and plus the other one is here, the whole of this is a constant, so I can simply write this as this constant 1 minus 2x over pi, then times the integral of t squared. I'll have t cubed over 3 from 0 to x. Okay, so the first one, when I put pi on 2 in place of t, so here I'll get pi squared over 4, because pi on 2, when I square it, I'll get pi squared over 4 times x over 2, and that will give me x pi squared over 8. Okay, then minus, when I put pi over 2 in place of here, okay, I'll have something like pi cube over 8, because 2 cube is 8. Okay, so I have, and pi cube over 8 times the whole of this will give me 2x over 2s pi cube, over 3 pi times 8, and that will give me 24 pi. Okay, that's for the first, putting pi over 2 in. Then minus, I have, putting x in, I have s in place of t squared will give me s squared times x over 2. I have s cubed over 2 minus, and putting x in place of t cubed, I have s cubed times s, 2x over 3 pi. I have 2x to the power 4 over 3 pi. Okay, so I have that, all of these, then plus 1 minus 2x over pi. Now I put x in place of t cubed over 3. I have s cubed over 3, and I put 0 there. I have 0, so I only have that part. Okay, so now let's try to simplify some terms. Okay, I hope you'll be able to simplify these. So this pi will cancel one of the pi cube, okay, and so what we'll have, or what will be left, will be pi squared at this top here, okay. So I have pi squared, and let me write it well, and 2 goes here 1 and goes here 12, okay. So this means that I'll have pi squared over 12 actually here, okay. Pi squared, or x pi squared, okay, x pi squared over 12. I hope you get this. So let's expand. I'll be expanding everything, so I want you to copy this and write it somewhere, okay, so that when I expand it doesn't confuse you. So with the expansion, I have x pi squared over 8 minus x pi squared over 12, then minus s cubed over 2, then plus 2x to the power 4 over 3 pi plus s cubed over 3 minus 2s to the power 4 over 3 pi. Now I've expanded everything. I've actually expanded everything. And I realize that that last two terms was as a result of this. I just multiply s cubed over 3 through this. I have first term is 1, so 1 times I have 1 over 3 s cubed, or s cubed over 3. And multiply to the second one, I have 2 minus 2s to the power 4 over 3 pi, okay. So I have plus of this, minus of this, so they go, okay. So here with the first two terms, I have s pi squared out, then I have 1 over 8 minus 1 over 12, and I hope you can simplify this fraction. Now with this part and this one, I have plus s cubed out. Now here we'll be left with minus half, so minus 1 over 2 plus 1 over 3, or you can write it 1 over 3 minus 1 over 2. And so after simplifying everything, we have s pi squared over 24 minus s cubed over 6. And realize that this is the final answer for this. For which one? Where is my y of x? So y of x is equal to now I want to write it here because it's equal to these, and we know that this part gave us what? So y of x is equal to, this is how tedious using the Green's function becomes, okay. G of x t y of t dt, then minus this part gave us s pi squared over 24 minus s cubed over 6, okay. So when you do the simplification there, you have y of x being equal to, now minus of everything, so I have s cubed over 6, it will be positive, then minus s pi squared over 24, okay, 24 plus, so plus the integral side, okay, plus lambda integral from 0 to pi over 2 g of xt y of t dt, which this becomes our free term, and lambda is still lambda because we don't know lambda, okay. Now you realize that there's a still g of xt, so in your answer you define your g of xt. So this is your final answer though, but then you write where g of xt is equal to, then you write it like 1 minus 2t over pi x from 0 less than equal to x, okay, less than t, then 1 minus 2x over pi t less than x less than equal to pi on 2. Let me erase that and write it well. T less than x less than equal to pi on 2. So this is your final answer, okay. You write this as your solution, then you define where your g of xt is that. Okay, so I have a trial for you and their expected answers. So I give you the trial, I write the expected answer, and write the g of xt you get. Okay, so the first trial is use grand function to convert this to FIE, y prime plus y equals x. Okay, then y of 0 is equal to y of 1 is equal to 0. Okay, to FIE, we're using grand function. The expected answer is y of x is actually equal to integral from 0 to 1 g of xt y of t dt, then minus this is the free term 1 over 6 into 3x minus s cubed. Okay, where your g of xt would be equal to x, then 0 less than equal to s less than t, then t where t is less than x less than equal to 1. So this is the first trial. Now the second one, I hope you've seen everything. So this is the expected answer with its kernel as this. Okay, so kindly go through it and give me a comment in the comment section too, for me to know that you're able to do it or not. Now the second one is y prime plus xy equals 1, and y of 0 is equal to y of 1 is equal to 0. Now the expected answer is y of x is equal to integral from 0 to 1 g of xt as usual, y of t dt, then minus half x into 1 minus x. So this becomes your free term, and your g of xt now becomes your kernel, where the g of xt is equal to x into 1 minus t. Okay, then t into 1 minus x. Now I know the limit already. Less than equal to x less than t, then t less than x less than equal to 1. Okay, now the third one, let me give you a third one, and all of these kindly go through them. Okay, let me give you a third one so that you get all kinds of questions that can come. Okay, plus lambda y equals e to the x. Okay, now subjected to y of 0 is equal to 0, so it's equal to y prime of 0. Okay, so these conditions are really tricky. It's equal to y prime of 1, so y of 0 equals y of prime of 0, and y of 1 equals y prime of 1, and then the expected answer is y of x is equal to integral, or let me write it for you, e to the x plus lambda integral 0 to 1 g of xt y of t dt. Okay, and then your g of xt is actually equal to negative into 1 plus x, then t 0 less than equal to x less than t, and negative into 1 plus t into x, t less than x less than equal to 1. So with the last trial, okay, let me talk about this, the third one. You realize the conditions are different. So you see, when you get to the second point where we say that g of xt should satisfy the boundary condition, now you take g1 of 0, okay, should be equal to g1 prime of 0. This is what you do. And with the second one, the same thing, g2 of 0, sorry, g2 of 1, because 1 will belong to g2, should be equal to g2 prime of 1. So that is the idea behind this. Okay, so thank you, and don't forget to subscribe to my channel if you have not subscribed. Like I said, this is our last lesson on integral equation, but I'll update it on how to solve voltarized integral equation. Thank you, and all the best in your exams. See you next time.